Hi friends, in this video we are discussing evolution of integrals of the trigonometric functions. Those are tanx, cotx, secant x and cosecant x. That is integral of tan x dx, integral of cotx dx, integral of secant x dx, integral of cosecant x dx. But before solving these problems, we recall the following formulas. Friends, you see the derivative of sin x is what? Cosine x. So the integration of cosine x, what you can say? Sin x. Derivative of the cos x is minus sin x. So integration of sin x, what we have? Minus cos x. Derivative of x to the power of n plus 1 is n plus 1 into x to the power of n. Then integral of x power n is x to the power of n plus 1 by n plus 1. Derivative of e to the power of ax is a into e power ax. So the integration of e power ax is e to the power of ax by a plus constant will come in the indefinite integral. Okay. Now integration of tan x is secant square x. Derivative of tan x is secant square x. Derivative of cot x is minus cosecant square x. Derivative of secant x is secant x into tan x. Derivative of cosecant x is minus cosecant x into cot x we have. But you observe the right side part. Have you from this what you can say? Integration of secant square x is a tan x. But will you say integration of secant x? Are you getting anywhere? No. Here also you see cot x integration minus cosecant square x. So integral of cosecant square x you can say minus cot x. But will you say where you have like right side part is tan x or cot x or secant x or cosecant x? No. So you cannot get directly. In this case we have to go for the substitution method. There are three theorems are there in the indefinite integral, especially these theorems. Those are called substitution method. Based on that we can find out evolution of the trigonometric functions. Those are tan x, cot x, secant x and cosecant x. Now we will discuss those three theorems. Let it be integral of f dash of x by f of x dx form. Friends, you see integral of f dash of x by f of x dx if you have, then we have a formula log of f of x plus c. You observe this is containing numerator and denominator. Whenever you have like numerator and denominator, in differential equation we have a u by v. U by v is nothing but vu dash minus uv dash by v square. But in the integration we won't have the direct formula. So if it is possible, verify the given function if it is containing rational fraction, that is like f dash of x by f of x form, nothing but denominator derivative if it is in the numerator. Denominator derivative if it is in the numerator, then you write a log of denominator plus c. For example, you see we discussed earlier 1 by x dx. This is in the form of this is like a numerator and denominator containing, the function is containing numerator and denominator. Yes. Now you observe, if you consider this is f of x, what is f dash of x? X derivative is 1, that is in numerator. So what you are writing this as? Log mod x plus c. So this integral 1 by x formula is came from this formula only. Okay, you don't have a u by v rule directly. Whenever the numerator and denominator is there, you have to verify f dash of x by f of x dx form. If it is not in this form, then we have a different methods. Okay, if it is in this form, then you can apply this one directly. Next, mainly to solve these problems, mainly we will apply this integral f dash of x by f of x dx. And more second one also I am discussing, you see integral of f dash of x into f of x all to the power of n dx is equal to f of x power plus 1 by power plus 1 plus c. You see friends, here you have f dash of x into f of x power n, nothing but product of the two functions. Whenever product of the two functions are there, in the derivative you have uv dash is equal to uv whole dash, nothing but derivative of uv is uv dash plus vu dash. Simply you can say first term into second term derivative plus second term into first term derivative, but not in the integration. In the integration what we have to verify, if suppose there are product of two functions are there, we have to evaluate the integration, like integrand is like product of two functions. Now you verify one function derivative is beside or not. If one function derivative is beside, then you write down power plus 1 by power plus 1. See, f of x power n is there, f of x derivative is beside. So what you can consider means power plus 1 by power plus 1. Next, third formula. Example example also I am giving. You see, what is the example I can give means here? Yes, we done x to the power of n dx. Okay, x to the power of n dx is there. What you written? X power n plus 1 by n plus 1 plus c you written. You see, x to the power of n is nothing but x bracket power n into 1 dx. Now you see, if you consider f of x is x, what is f of x derivative? F dash of x. What is f dash of x here? 1. So x derivative is beside or not? You see, f of x derivative is beside. Now if you consider f of x as x, x derivative is beside. So what you can write now? That f of x power plus 1 by power plus 1 plus c. Is it clear? Now next one is, third one we have f of g of x. F of g of x into g dash of x dx. Means here you see, this is f of x into f dash of x type. But here f of g of x dx, nothing but function of function, combination of the function here, function of the function, fog you can say. If it is in this form, this bracket derivative is beside, function derivative is beside, then you can say this one is f of g of x plus c. For example, you see, integral of e to the power of 3x into 3dx is there. Then you see friends, here it is in the form of f of g of x. F of x means here e power t, where t is here g of x. This 3x, sorry, integral e power 3x into 3 dx is there. This 3x if you consider as the g of x, then 3x derivative is beside. Then integration of this is e to the power of e power bracket derivative is e power bracket only. So e power bracket plus c. One more example also I am giving. You see, e to the power of sin x into cos x dx is there. Now you see, this is like f of g of x. What is the g of x here? Sin x. Sin x derivative is what? Cos x. That is beside or not? So what you can write this means e to the power of sin x plus c. One more example I will give. You see, integral of sin 3x plus 2 into 3 dx is there. Okay. Now if you consider 3x plus 2 is a sin, 3x plus 2 is a function g of x. What is the g dash of x here? 3. So this integration is here. Sin x integration is minus cos 3x plus 2 plus c. That's it. Is it clear for everyone? Right. Now we will discuss the integral of tan x, cotx, secant x, cosecant x by substitution method. Friends, we have a tan x formula. Tan x is equal to sin x by cos x. Yes sir? So what you can write now, integral of tan x, just you apply integration on both sides, then integral of tan x dx is equal to integral of sin x by cos x dx. Now this is like u by v rule. Friends, already we are discussing in the derivative you have u by v rule. U by v rule only for the derivative v u dash minus uv dash by v square. But whenever integral in the integration we have like a u by v rule, u by v form. Whenever we have u by v form, then we have to recall the first formula we have. Denominator is f of x and numerator is f dash of x dx. So f dash of x by f of x dx if we have, then we have a formula log of mod f of x plus c. So if the denominator derivative in the numerator, then we are writing log of f of x plus c. Now what is the cos x? What is the denominator you have here? Cos x. Cos x derivative is minus sin x. Is there minus sin x directly? No. So what I am doing means multiply twice. Okay, inside and outside. Then you will get a same answer, because minus 1 square is nothing but positive only. Now integral of. Now you observe the denominator derivative in the numerator. So what you can write? Minus log of mod cos x plus c. So you have a formula n log a is equal to log a to the power of n. So you can write log of cos x whole inverse plus c. Log of cos x whole inverse 1 by cos x is equal to, you can write as secant x. So this is log of secant x plus c. Friends, you can answer minus log integral of tan x dx is equal to, you can answer minus log cos x plus c or log of secant x plus c. Both you can write. Is it clear for everyone? So what is the answer for this? Integral of tan x dx is equal to minus log of mod cos x plus c, or this is log of secant x plus c. Okay. Now we are discussing integral of cotx. Generally cotx you can write as cotx is equal to cos x by sin x. Now you apply integration on both sides. Then integral of cot x dx is equal to integral of cos x by sin x dx. Now you observe it is containing u by v form. But in the integration you don't have u by v form. Whenever in the integration you have the numerator and denominator, first we will cross check with the formula, substitution formula, that is if it is in the form of f dash of x by f of x dx, then we will write log mod of f of x plus c. Now you observe denominator is a function. So this function derivative is what here? Sin x derivative is cos x. So you can write log of mod sin x plus c. Friends, this problem you can do in another method also, that is substitution method. How you can do, I am explaining now. You see, in method 2, let f of x is equal to sin x. F of x you consider previously. Now you consider f of x is here sin x. Sin x you consider t. Sin x you consider as a t. So introducing new variable t. Now sin x derivative is cos x dx is equal to dt. Just you are differentiating on both sides. Then sin x derivative is cos x into dx and t derivative is dt. Now you substitute these two values in this equation. Then you will have integral of, you see, 1 by sin x. 1 by sin x is nothing but 1 by, just you have in the denominator 1 by sin x is nothing but here. You see, first I have cos x dx. Cos x dx is nothing but dt divided by sin x in the denominator. So in place of sin x, what I would write? T only. So this is the formula. Now you observe integral of 1 by t dt is nothing but what? Log t. Log mod t plus c we will write. So what is the t now? T we are replacing by sin x plus c. So in both methods you can do. Is it clear? General method is, if you consider this as f of x, then you can write directly. Otherwise you can substitute sin x as a new variable, treat as a t. Okay. These type of the problems we will discuss later. That is why I explained both the methods here. Next, third one, what we have? Friends, now we are solving integral of secant x. So integral, generally secant x is equal, we will write as 1 by cos x. But from that 1 by cos x, we cannot get the solution. So what we are doing means, for the secant x dx, we are multiplying and divide with secant x plus tan x. Multiplying and divide with secant x plus tan x. Okay. Now multiply inside, then what you will have? Numerator will be secant x into secant x means secant square x plus secant x into tan x divided by secant x plus tan x into dx. Now again it is in the form of u by v. U by v or not. Whenever u by v form, then you verify with the f dash of x by f of x dx form. So if denominator f of x is there, denominator derivative in the numerator, then we are writing log of mod f of x plus c. Log of mod f of x plus c. Now what is the denominator you have? F of x is equal to secant x plus tan x. Friends, I told you this one you can consider as a t also. Now I am explaining, I am considering as a new variable t. Of course f of x, not an issue. Now if we consider this as a t, now differentiate on both sides. Secant x derivative is secant x into tan x plus tan x derivative is secant square x into, you have here dx, here also you have dx. So I am writing dx is a common term and outside. Now dt, t derivative is dt here, right? You observe this denominator, these two values you substitute in the above integrand, then what will happen? You see, denominator want to have secant x plus tan x, so that is 1 by t. What is the numerator you have? Secant square x plus secant x tan x. Here you have secant square x plus secant x tan x. So that is into dx. Into dx is there. So in place of that, what I get? Dt. So this is 1 by t dt. 1 by t dt integration. Denominator t derivative in the numerator. Denominator if you consider as f of x, this derivative in the numerator. So log of mod t plus c. Now you replace t by secant x plus tan x. Then you will have secant x plus tan x plus c. So what you can say now? The secant x integration is log of mod of secant x plus tan x plus c. Friends, this one you can also say like in this form, in the function of tan of pi by 4 plus x by 2. You can write like this also. Okay, you have two formulas. Integral of secant x dx is log of secant x plus tan x, and log of tan of pi by 4 plus x by 2 plus c. You can write both. Okay, remember, while solving some problems we will use this one, especially in MSET and IIT JEE we will use this one. That is why I explained here. Is it clear for everyone? So to evaluate the secant x, what we have to do? We are multiplying with the secant x plus tan x. Okay, multiplying and dividing also. So that function we are considering as a denominator f of x or else a t. Anyone you can consider. Then you will get the solution. This is integral of secant x plus tan x. Integral of secant x dx is integral of secant x dx is log of secant x plus tan x or log of tan of pi by 4 plus x by 2 plus c. Now integral of cosecant x dx. Friends, you see we have a cosecant x as 1 by sin x, but with the 1 by sin x we cannot do anything. So what we have to do means to find out this integral of secant x dx, just we are multiplying and dividing with cosecant x minus cotx. On multiplying cosecant x and dividing with multiplying and dividing with cosecant x minus cotx into dx. Then multiply inside, then you will have cosecant x into cosecant x is cosecant square x minus cosecant x into cotx divided by, you have cosecant x, this is cosecant x minus cotx into dx. Now you observe this is containing numerator and denominator. So whenever u by v form, okay, you have to remember integral f dash of x by f of x dx form only. So whenever the denominator derivative in the numerator, then we will let log of denominator plus c. Now you consider this is f of x, or else you can consider this is f only variable t. You can consider with a function, or else you can consider as a t. Suppose I am considering this cosecant x minus cot x as a t. Okay. Now the derivative of cosecant x is, we have minus cosecant x into cot x minus cot x derivative is minus cosecant square x into dx. Dx is here also you have and here also you have. I am taking common into dt. Is it clear for everyone? Now you see in this one, multiply here minus into minus plus. So I can write this as cosecant square x minus cosecant x into cot x dx is equal to dt. Now substitute these two values in the above equation. Then you will have integral of cosecant x dx is equal to integral of, you see cosecant x minus cot x, what you consider t. So that is in denominator. So write down 1 by t. Next cosecant square x minus cosecant x into cot x, cosecant square x minus cosecant x into cot x dx as what you consider dt. So dx is also there, you see. So this is dt. Now you observe the denominator derivative, t derivative in the numerator. So what you will let here, if the denominator derivative in the numerator, then we will let log of denominator plus c. Therefore this is equal to log of mod t. T, what you consider t as cosecant x minus cot x plus c. Therefore what you can say the formula, integral of cosecant x dx is equal to log of mod cosecant x minus cot x plus c. Okay friends, also you have another formula, that is log of tan x by 2 plus c. We will discuss this formula later. Is it clear for everyone? Right. So integral of tan x dx is equal to minus log of cos x plus c or log of secant x plus c. Integral of cot x dx is equal to log of mod secant x plus c. Integral of secant x dx is, you can write as log of secant x plus tan x plus c or log of tan of pi by 4 plus x by 2 plus c. And finally we have integral of cosecant dx, that is log of mod of cosecant x minus cot x plus c or log of tan x by 2 plus c. Friends, in the next video we will discuss the problems based on the substitution method. Right? Thank you for watching this video.